Hello everyone, this is John from Vulgar Kitten Studios, and welcome back to our third-person controller tutorials in Unity using mecanim. And so in this tutorial we'll go ahead and work on our player camera system. So just open up that script in mono development, and the first thing you need to do is go ahead and include your helper class with a using statement. Just add in helper. And again, I'll be giving this a summary, so pause the video if you want to read this or copy this. Okay. And so we'll just go ahead and dive right in and start getting this done. So we'll go through our variables, so we'll set up a few private fields and properties, and this is going to be used to position the camera. So we'll need to create a new vector3, and I'm calling this camera normal position, so this is when it's in the normal state, and we make that a new vector3 and then whatever values it is. The way that I found these values is I actually just in Unity I just created a new game object in the scene view. I just create a new game object by going to game object and create empty, and go into orthographic or ISO, and then just position this at a point behind the character that I want the camera to be located at. So something like this, and then just copy in the transform values. So you can use that same method if you want to do that with your system as well, but I'm just going to go ahead and delete that, and we'll get back to setting this up. So there's our normal camera position vector, and we're going to need some values to rotate the camera. So I'll add another comment, and the first thing that we'll need is a sensitivity. So if you want to use the right Y or the right Y axis on your Xbox controller to be able to look up and down, then you can set this. You can set this as well. And I've also made this serialized, so it's a serialized field, so you can edit that in the inspector if you want to tweak with the values. Okay. And we'll also need a minimum angle and a maximum angle to clamp that, so that way we can't orbit all the way around the character. Like let's say that we're actually playing the game, like in the editor view you can actually flip the entirety of the camera all the way upside down. Without clamping that value, you'd be able to do the same thing in game, and it just doesn't make for very intuitive gameplay. So we're going to clamp that. Okay, and we'll also need a cached reference to our rotation, so I'm calling that rotation Y, and this is going to be the actual rotation at which we set that Y axis to in the camera. We'll need two transforms, one for the camera and one for the player. So I'm just calling mine underscore camera and underscore player, so that we can actually get the transforms of each of those objects. We'll need a private reference to our player character script, so we'll make that of the data type player character, and I'll just call mine PC. We'll also need a reference to our camera state enumeration in our helper script, so I'm just calling mine state, and I'm defaulting that to camera state.normal. We'll also need two references for each of our camera mount points, or for our objects that we'll be creating with the structures used in our helper class. So we make that of the data type camera target object and camera mount point, and I've just called them the same with an underscore and a lowercase first letter to keep things consistent and simple. Okay, and we'll need one accessor for our camera state, so we'll say public camera state and just call that camera state and return the state, so that way we can also give it corresponding code in our player motor depending on the state that the camera is actually in, and vice versa. Okay, and so in our start method we'll be doing a similar check as we did in our player character script for the network, or for the network view, and we do this just so that we can give it the ability to be played on either a multiplayer or single player platform. And so we just check if the network view belongs to this instance or if it's disconnected, and if it does meet these conditions, then we start the script, else we just disable the script entirely. Okay, so we want to set the player character reference. We'll set that to be this.getComponent player character. So we want to get the player character of this instance. And we want to get the camera's transform. So we'll set the camera equal to GameObject.findWithTag. And again, we're using our helper class, so we're saying GameTag.playerCamera. So it's going to find that object or that camera that we tagged player camera earlier. And we want to make sure that we get the transform of that, or else it'll throw an error saying that it can't convert a game object into a transform, because we actually set our camera variable to be a transform type. So we want to get the transform component of the game object that we find. And we want to set the player's transform to be this.transform, because our player camera script is actually attached to our player and not our camera, which is a little bit backwards from most from what you might have seen. But the reason that we do it this way is because we want to be able to manipulate one camera if we are in a multiplayer instance. And so that way we don't have many different cameras that are causing conflicts or slowing down our processor for no reason. Okay, and we want to then create an object for a player to look at, or for a camera to look at. And the way that we do this is, first of all, we initialize our camera target object variable to be a new camera target object, and then we call the init method on that and give it the values that we want it to use based on the structure. So first we give it a name, and I've called mine camera target. We give it a position, and I've just set mine to have the y-axis of 1. Then we want to instantiate a new game object and get the transform, and then we want to set that parent. So we want to set this game object's parent, and we're setting that to be the player, so that way this transform or this game object will always be following the player around. Okay, and so we want to do the same thing just with our mount point. So we'll create a new mount point, and actually give it a comment here. So create an empty object at runtime for the camera to sit on, and we'll call the initialization method again so that we can set those values that we define in our structure. It looks pretty much the same way. I'm going to change this. I'm going to call this camera mount, except for the position, instead of giving it a new vector 3, we're going to use this vector that we calculated up here. So set that to camera normal position. Then again, we instantiate a new object and get the transform component of that, and we set the parent of this object to be the camera target object. So the object that we created here is going to be the parent of this object, and that way we can rotate this object, and this object will inherit that in local space. Okay, and you'll see how this works in just a few moments. So we want to go ahead and set the camera's parent to be the camera target object, so that way the parent or the camera will always be on that mount. Okay, so now we can go ahead and start working in our late update method, because instead of using update here, we want to use late update, and that's just so that we can ensure that any calculations made about the player's movement happen before we do the camera. We execute the camera code, and so that way lerps turn out right, and so on and so forth. We won't actually be diving too much into that in this series, but definitely at a later state we'll be working with that. But in our late update method, we want to set up a state machine, and so we use a switch statement to do that. And we want to switch on a variable, and the variable we want to switch on is the state variable. So this reference to our camera state here. Okay, and inside of a switch statement you also need cases, so this is just an easier way to construct an if statement. But we'll go ahead and say in case the camera state is equal to normal, then we want to execute some code in here. Okay, so we'll go ahead and set up another one for our target as well. So case camera state target, and that with a colon, not a semicolon, and then a break statement to end that case. Okay. Now before we start executing the code for our camera, I actually want to create another custom method, and I'm going to call that rotate camera. So that way, anything that if we needed to set up another state machine in here, we could, or if we need to do any kind of complex math, we can do that in here. But what we're doing really isn't that complicated. We want to take that rotation variable that we're using to cache the rotation of our camera, and we want to set that, or we want to subtract from that the input axis right Y. Okay, so moving the right stick on your Xbox controller up and down, and then multiply that by the sensitivity. Okay, and then we want to set that to be clamped between our minimum and maximum angles, and we use mathf.clamp to do that. Then we actually just want to go ahead and set our camera target object to be equal to that rotation, so that the object itself rotates, and since the camera is parented to the object, it'll inherit that. Okay, so we call the camera target object.xform, or the accessor that we set up in our struct here, so camera target object and the accessor for the xform, and then we make the local Euler angles equal to a new vector 3 and just feed in the rotation value, and then our own local Euler angles dot y, and then 0 for the z. Okay, and now we want to go ahead and call this method in our normal state. So that way, because this is in late update, anytime that the camera state is in normal, then whenever we move the right X up and down, then it'll go ahead and rotate that camera for us. And we want to set the camera position to be equal to our mount position. So whenever it's in the normal state, then our camera mount position, the object that we place with our structure, will act as a reference point for our camera to kind of sit on. And then we just want to make it look at something, so we'll use the camera, since this is a transform type, we'll use the look at method for that and just make it look at the X form of our camera target object. And that is literally it for our camera system. So we'll go back into Unity and we'll let this compile, and now we can click on beta, go to add component, go to app, and player character. Then all of those requirements that we added in our player character script will be added here, including the player camera. So now if we just play, now we can look up and down, and that's it. That's it for our camera tutorial. I'm not really sure why this isn't defaulting to our idle animation. Let me check this. Okay, so I'm sure it has to do with the parameters in here. So it looks like, alright, I know why. It's because it's not grounded. Alright, so that does it for our camera controller, and we'll go ahead and work on the player motor in the next tutorial. I'll see you then.